Hello everyone, I'm Aggelos Kiayias, Chief Scientist at Input Output and a professor at the University of Edinburgh in Scotland, UK. In this presentation, I'll give you an overview of Input Output research, the work that has been carried out so far and what lies ahead. The research mission of Input Output is to contribute to the blockchain space in three fundamental ways. First, by performing foundational and applied research to solve the many critical open questions that this technology has brought forth. Second, by disseminating the research outputs freely for the benefit of all, allowing both timely access and subsequent development to take place by the community. And third, by supporting research efforts of the whole community, contributing to peer review of other people's work and sponsoring research conferences and other dissemination efforts. Now, you might ask why research is important and why we should invest in it. Basic scientific research, both applied and theoretical, is essential for the blockchain space because it allows us to resolve fundamental issues related to correctness and security of these systems. Correctness is paramount in blockchain technology. Blockchain protocols and smart contracts are components of a critical infrastructure. As such, deviations between designer intent and runtime behavior can be catastrophic. There are many examples of that nature that have plagued the space from early on. You can start from the infamous DAO attack in the Ethereum blockchain to the very recent Polynetwork hack. There is a list that goes on and on. So basic research provides techniques and methodologies for ensuring correctness of computer systems, both at the platform level and the application level. Security, in the sense of resilience to faults and resilience to participant deviations, is another central property of the blockchain space. It is also a very elusive concept. Post factum, after an attack takes place, let's say, lack of security is observable and demonstrable. But then it is also too late. So security, the absence of such events, the absence of attacks, means that nothing bad will happen. But how can we establish this? It is not enough that the system's security is a proposition that makes sense to the average user, or even that the system has been reviewed by someone who is competent, who tried to attack it and then failed. What is needed instead is first principles modeling and proofs that demonstrate the system retains its security against any plausible attack. To achieve this, we need theoretical foundations, and these include mathematical models within which systems can be analyzed and even proven secure. Furthermore, we need to facilitate the comparison and classification between various systems. Otherwise, it is impossible to compare them with each other. And this is quite essential. Let me explain this with a small example. In most systems, there is an obvious performance versus security trade-off. This means that you can make the system more performant and usable by sacrificing its security. So when you have two competing systems, it is easy for one to surpass the other in terms of performance by sacrificing security. So if the systems get locked in a race like that, with one leaping ahead of the other continuously, decreasing security again and again in every step of this process, it becomes a race to destruction. In the end, an attack is bound to happen. So this is something that by all means needs to be avoided, and that is why we need to have well-defined frameworks for defining and arguing security in the blockchain space, and develop standards that establish what are the fundamental security requirements that every system should adhere to. With this introduction, let me now turn to our research highlights and also the work that you will expect to see in the coming years. I'll start first with the Cardano contract layer. which is the centerpiece of this year's summit. The system offers a general-purpose platform for decentralized applications. This is centered around the Plutus language, based on research that we've been working on the last 5 years, and culminated in outputs such as the extended UTXO model and its native tokens, results that were peer-reviewed and published last year. This general-purpose layer gives rise to domain-specific languages, or DSLs. An example of such language is Marlow, a language for financial contracts that is covered in another presentation in this summit. Developing applications in Cardano takes place over the Plutus application framework, which is another development of research and engineering coming together. Now, let me cover some of the ongoing research work. First, we're currently doing a deep dive on pricing models for smart contract transaction processing. Some first highlights of this work you can see, for instance, in the bubble fees and stable fees panel that is also in the program of the summit. There is also very exciting work that is coming up in the direction by a research team, that includes dynamic pricing models, which adjust automatically the fees in Cardano so they always remain predictable and fair. Another interesting domain that we're looking into right now is blockchain storage. Storage is a precious resource in a global transaction ledger, but it's also quite essential if we want to have fully functional and general-purpose smart contracts. So we're working on the area of distributed databases and storage protocols to enhance the smart contracts capability with as much storage as they require. Another line of work aims to build formal verification tools for smart contracts. So with such tools, it's possible to build decentralized applications on top of the Cardano blockchains that will be formally verified. While another line that you should expect to see a lot of development is new DSLs for various domains that will extend the developer community of the system. Let's go a bit deeper now and further down in the protocol stack and look at the settlement layer. This is where the Ouroboros protocol lives. Undoubtedly, this was one of the major achievements of our research team over the last 5 years. We delivered groundbreaking advances in proof-of-stake protocol design with the Ouroboros protocol in 2016, and these were further improved with resilience against adaptive attacks and bootstrapping from Genesis in 2017 and 2018, respectively. These provided the solid foundation for the Cardano ecosystem. It's worth saying that one of the fundamental drivers behind the research that we did for Ouroboros was the energy efficiency of the underlying network. This would be contrasted to, for example, Bitcoin, that is a protocol which does not distinguish energy sources, and it will hungrily consume vast amounts of energy, currently on par with a medium-sized country in annualized consumption. In contrast, the Ouroboros network consumes only a modicum amount of energy per node. And while Ouroboros can be scaled via Hydra, our layer 2 protocol extension, we have continued to consider ways we can optimize the throughput and latency of the main chain protocol. Further, we're also interested in increasing further its security characteristics. Our ultimate goal in this direction is the development of Ouroboros Omega. We cover this work in another presentation in the summit that I invite you to attend. This protocol design will also lead us to the 4th generation blockchain systems that go beyond stake or work. Multiple resources of various forms, including reputation and merit, can be weighed in and acted upon in such a system. Let us now move to tokenomics. With the introduction of our research in reward-sharing schemes, in 2018 we gave the first instance of a game-theoretic mechanism for incentivizing collaborative projects that was analyzed for equilibria and dynamic converges to such equilibria. This was implemented in the Cardano incentivized testnet in 2019 with very positive results and then rolled into the mainnet last year. We continued the formal modeling work studying the incentives of blockchain systems during this time, as well as engaged in the development of other systems and concepts such as stablecoins, for instance with the development of JED that was released just this year. What we're aiming for in the next years is to develop these capabilities to a broad set of features that are available to the whole ecosystem. This means that it will be possible for groups of people to engage in user-defined collaborative projects that have sound economics. Other important targets is the development of stable fees and stable coins and integrating them into the Cardano mainnet. This is also covered in another panel in the summit. Let's now move to blockchain governance. This is one of the most important pieces of work that is upcoming in Cardano in the form of Voltaire. We have already done groundbreaking work in the form of the treasury system that was published in 2019. That system facilitated the concept of privacy-preserving delegation of voting. Now, with this feature, the system can allow an agile form of decision-making, where users can delegate their voting rights or vote directly without disclosing which path or option they choose. At the same time, the first step of decentralized governance took place in the form of Project Catalyst, which launched in 2020. So there is a number of features and properties that the research team is currently working on. Actually, documenting the relevant properties for proper governance is an important task in its own right, and one that we're currently investing significant time. So I'll take a few moments to go over some of the concepts that are relevant for blockchain governance. And we have been studying and analyzing, systematizing their capabilities and their requirements. The properties include privacy, which refers to the ability of people to protect their vote from becoming disclosed, and the related property of coercion resistance, which means that users should be free of external influences in the way they participate in a governance mechanism. End-to-end verifiability is the ability to verify that the system has correctly recorded the user's intent. Accountability is the system having the capability of making the users bear some responsibility for the actions they take collectively. Thus, it should be hard for someone to influence the system in a bad direction and then not suffer some of the consequences in a fair and proportional manner. Sustainable are systems that are capable of making the right decision. This also means that the system is capable of identifying subpar performance in decision-making and reacting accordingly to that. For instance, adjusting reputation of responsible actors. Pareto efficiency asks for a suitable alignment between the final decision of the governance process and what each individual wants. And this is a necessary property for the results of the decision-making process to be acceptable by everyone. Liveness suggests that the system is responsive in a timely manner, and that's an essential property in many cases, especially if we have to patch vulnerabilities and issues that arise in terms of the security of the system. And finally, suffrage refers to the inclusivity of the system. We have to make sure that the relevant stakeholders are always part of decision-making. So you see, there is a wider array of properties that are needed in governance systems, and we are formally investigating all of them from a first principles perspective. And furthermore, we consider ways that we can construct governance protocols that they satisfy them by design. Let's enter now layer 2. The Hydra head protocols will form an important part of the Basho era of Cardano. A milestone here is the development of the Hydra head protocol that we published in 2019. This work introduced the concept of isomorphic operation between layers, which means that the applications can seamlessly port it from the main chain layer to layer 2. The full suite of protocols for Hydra will facilitate optimal performance close to the physical limits of the internet, and trustless operation as the underlying main chain can always play the role of the arbiter in any dispute between the participants. Now, what you should expect upcoming in our research in this area is the tail class of protocols, which will enable very fast processing of smart contracts, even for parties that are intermittently online, as well as the inter-head and tail communication protocol, which will enable the joining of multiple head and tail instances to a versatile and extensive layer 2 network. Moving on to the sidechain ecosystem now. This enables Cardano to listen and react to events in other systems, as well as become extensible with various non-native capabilities. A milestone in our research work was the development of the concept of proof-of-stake sidechains that we published in 2019. This work, among others, showed how sidechains can be used to extend the main chain capabilities with various features. These, for example, could include compatibility with other smart contract languages or experimental features. At the same time, we developed the concept of non-interactive proof of work, which paves the way for completely trustless integration with proof of work systems such as Bitcoin and Litecoin. In the same research, we are working towards secure oracles, which will enhance the capabilities of smart contracts with external data feeds. And we're also developing general-purpose cryptographic toolset for seamless flow of value of information between different blockchains, be it proof of stake, proof of work, or otherwise, without single points of centralization. Final point, but quite important, is our investment of significant efforts to the post-quantum security of the whole protocol stack of Cardano and blockchain protocols in general. We've started this work, first principles, by studying blockchain security in general in the post-quantum setting for proof-of-work systems. In the future, we will be developing ourselves as well as collaborating with other blockchain system development teams and analyzing post-quantum algorithms and protocols for the Ouroboros protocol and other critical components that are related to the Cardano ecosystem. Note that this will not require the enhancement of the system with any quantum capability. Instead, the system will remain classical in the computer sense. However, it will use suitable algorithms whose security remains unbreakable even against all-powerful quantum adversaries. Now, this gave you an overview of all the questions that our research team handles at the moment, as well as the direction we're heading. In the next few slides, I'll give you a bird's-eye view of how we work at input-output research, and you'll get an understanding of how our day-to-day operations look like. First, by numbers. There are some 50 or so researchers working at various levels, either part-time or full-time with input-output. There are people either embedded in universities, PhD students, or full-time in-house researchers at input-output. We have 4 senior research fellows that have worldwide recognition in the areas of algorithms, game theory, regulatory technology for finance, and programming languages. The core team numbers 7 full-time in-house researchers and 3 research engineers who are also forming the connective tissue between the research organization and the engineering team. Over the years, we published some 92 papers, co-authoring them with researchers from both industry and academia, while we have currently some 18 papers under submission for peer review. The research operations of input-output span the globe, and there are some 13 countries over which we have research members. Now, collaboration is at the heart of basic research, and this basis input-output is very proud to have established research protocols with a wide network of top academic institutions around the world. In terms of research dissemination, this happens under the auspices of established international organizations that promote computer science research in a number of areas. These include the International Association for Cryptologic Research, the Association for Computing Machinery, the International Financial Cryptography Association, the IEEE, and the Internet Society. We're now at a great point in time in the development of blockchain technology. Years of hard work has borne fruit, but we're not done yet. In many ways, it is now that things get interesting. So, what lies in the road ahead? In the next 3 to 5 years, we hope to contribute to solving all the problems that are necessary for blockchain technology to become the global foundation of all information technology infrastructure. And importantly, we hope to be able to do that in the context of Cardano with the support of Cardano community, who are the ultimate custodians of the ecosystem. Input-output is committed to basic research. In order to meet our immediate research goals, we are expanding our team to build strength in a number of critical areas. These include game theory, social choice theory, human-computer interaction, economics, political science, management science, and financial regulation and policy. What you can see is how multifaceted and interdisciplinary is our agenda. These roles are in conjunction to areas of core strength of the research organization of input-output, such as cryptography, programming languages, and cybersecurity. If you do research in the above areas, or you just want to follow what the team is doing, keep an eye to iohk.io. This wraps up the Input-Output Research Overview. Thank you for joining this session.